Okay, let's get started. Good afternoon. My name is Jung-Soo Kim from Samsung Electronics. I'm taking charge of developing memory SSD reference system. I have my colleague here, co-presenter Toko. Toko is taking charge of storage OS for NVMe Fabric. So today, I'm going to talk about some benefits of EDSF. And I'm going to share our EDSF E1 and E3 reference system design. And Toko will present his Poseidon storage OS for NVMe Fabric. So since I don't have much time today, I only have 15 minutes, I'm going to go briefly rather than go over the details. So if you guys have any questions, please let us know after the keynote or by email. So EDSF has been a hot topic, especially in storage projects these days. And there are many webinars or materials that show the benefits of EDSF. EDSF is a future-proof form factor. It is designed to overcome the conventional device limitations, like a U.2. You can get a max like 25 watt with U.2, but with the EDSF, you will have 70 watt max power. So it is advantageous for capacity and performance scaling. It improves your thermal characteristic of the devices, and it increases the power capacity and scalability. So most of all, it provides many flexibility. As you well know, it provides various power options from 12 watt to 70 watt. Also, it provides various PCB tabs by 4, by 8, by 16. It has various sizes also. E1.S has 5 different thicknesses. E.L has 2 different thicknesses. E3 long, E3 short. So if you mix and match those options, you will have so many different various kind of configurations using EDSF. So I compared the EDSF with the traditional U.2 system with the E1.S and 1U and 2U U.2 SSD with the E3.S 2U system. So as you can see, with a traditional form factor, you can have 10 2.5-inch drives on 1U system. But with the E1.S, a 9.5 millimeter SSD, you will have 32 SSD in one system. So theoretically, you can increase more than 3 times of the capacity of your system. If you compare the 2U system, traditional system will have 12.4 U.2. This is very general option you can have. With the E3.S 1T with a thin device, you can literally have 40 SSD. So you have various power options. You have various thickness, and you can optimize your system according to your needs. That is the power of EDSF. So we started Poseidon project 2019, and we announced its first version of E1.S reference system last year, unfortunately in virtual summit. But Poseidon project is multi-industry collaboration program to develop open source-based hardware and software for NVMe Fabric, especially for E1.S, which is the first version of first hardware. So Poseidon project consists of both hardware and software. And we designed the system to optimize for the shared network storage system for NVMe Fabric. And it is a multi-collaboration project between the component vendor like Samsung and data center neighbor in Korea, and Inspur, the system vendor. So I'm not going to go much details because I'm already introduced the design last year at the OSP Tech Week. So if you can see, it has the 32 E1.S SSDs in front. And the platform is Ice Lake PCI Gen 4-based platform. It has two PCI switches to support full bandwidth of each SSD. So each SSD is connected by 4 lanes of PCIe. So I brought some performance numbers. On the graph on left, it shows each 32 SSDs performance. And if you look at the spec of PM983 E1.S SSD, the maximum performance is 6.5 gigabyte. On our system, you can see that from number 0 slot to 31 slot, it shows very stable and uniform I/O performs around 6.4 gigabyte. There is a little bit degradation of performance, but it is because the system has PCI switches to support the full bandwidth, and it increases the latency a little bit. We also measure the aggregated performance of 32 SSD from 1 to 32. So as you can see, there are like staircase-shaped graph. Since 4 SSD drive can easily saturate 16 lanes of a PCI switch, the performance started stable after 4 SSDs and increase again, and increase again, and increase again. So we could get over 100 gigabytes of local bandwidth. And theoretically, you can have 128 gigabytes with PCI 64 lanes. But so the local performance is about 80% of the theoretical bandwidth. We also measure some RAID performance with the RAID 0 and 5. On RAID 0, the blue graph shows the maximum performance you can get. And on RAID 0, all the SSD are very close to the read and write operation was very close to the maximum performance. However, on RAID 5, as you can see, the write performance was very poor. I think that is because there are some overhead on parity operation, and specific, some CPU cores were saturated. So we should study more, and we should find some better way to increase the performance on RAID 5 with us on the NVMe SSD systems. So I'd like to introduce some new design called two-list SSD design. So after we announced our Poseidon project last year, we got some feedback from data center users. So one of the feedback was they wanted to remove the screws from our SSD so that they can easily assemble and disassemble extension key from the E1.S SSD. I'd like to show you a simple video that shows on the right side, it only takes 4 seconds to assemble and disassemble extension key from the SSD. But on the left, it took 40 seconds. So you can, it's a lot of difference. There are 10 times difference between the traditional screw type extension kit with our clip type extension kit. So we designed this new extension kit with our partner Inspur, and we are going to open source our design to the OCP community. After that, we want to get some feedbacks and upgrade our design, and hopefully customer can adapt our design to their data center in the future. So how many of you heard our keynote yesterday, Samsung's keynote? Okay. So we announced our new E3.S reference system yesterday, and we called Poseidon V2. So V1 was for E1.S SSD reference system, and V2 system references E3.X devices. So we designed this system to maximize the benefits of E3.X form factor. Not only the E3.S, it supports all the form factors, like thick and thin, and short and long. So the benefits of EDSF is since it supports various power and thickness and size, you can have most of our PCI devices as E3 form factors. So we call this is the system can have not only the SSDs, but it can have any other PCI devices like a CXL memory expander that we showed on our booth, and smart SSDs where any like accelerators can be E3 form factors. So since our system accommodates those E3 form factor, if the system have E3 24 E3 SSDs, it can be used for high performance shared network storage system. Or if you install the CXL DRAM on our system, it can be used for high memory servers in the data center. And then also you can have the smart SSD or AI accelerators, and it can be used for the AI servers. So this is you can have very, E3 enables the composable architecture of traditional server systems. So to support 4 different types of E3 form factor, the system has 2 different type of backplane. So type 1 system has 24 connectors. E3 connectors supports by 4 PCI 5 lanes. Or type 2 system, you can have by 8 PCI 5 by L lane, 8 devices with PCI 4 lane, 8 E3.S1T devices. And the system shares the motherboard and cache, and on the backside of the system, it has the 2 OCP NICs, and DCSCM is also in backside of the motherboard. It's number 6. So BMC and security module is in DCSCM. So the system is based on the PCI Gen 5, and CXL based the EI 19-inch 2U system. So we are going to, the system is, now the system is the pre-production level system. So after we we develop for the production level system, we want to have some POC with the data center customers and internal in Samsung teams together. And we will also open source our Poseidon V2 system next year. With that, I'd like to pass my mic to my colleague, to Doko.
Hello, hi. I'm Doko Bae from Samsung Electronics. I'm taking charge of developing software solution for Poseidon project, which is called Poseidon OS. Poseidon OS is a kind of storage applications running on a Linux kernel, especially for environment fabric, which becomes more popular for storage disaggregations. It is open sourced because we want to develop and build ecosystem together. And Samsung is one of the best companies to handle NAND flash, so we want to put our knowledges and experience into this system to improve data center storage efficiency and performance as well. And I just briefly explained about the environment fabric interface. And with environment fabric interface, we can literally access a remote NVMe SSD through the network, with high performance and a low overheads. So by doing that, we can enlarge number of SSDs that can be controlled by the host from up to a few hundred to 10 or 100,000s. And again, Poseidon OS is a user space application and it runs on the kernel. And Basically, it supports embedded fabric interface, so it can provide virtual and customized block devices to the initiator. And it can fully provide PCI Gen 4 performance through the network, and also supports valuable storage features like volume management, performance throttling, software laid, something like that. It's for a single load solution, so it is inevitable to make Poseidon OS to easily integrate with upper orchestration like Kubernetes OSF with RESTful API and CSI, which stands for Container Storage Interface. And I have some performance numbers running on Poseidon V1, which is PCI Gen 4 system. And as you can see, Poseidon OS can achieve up to 200 gigabyte Ethernet performance with NVMe TCP, which in most cases, which spends more CPU cycles than RDMA. And I'd like to share our future plans with Poseidon system. And so far, we have two kinds of servers, which is V1 and V2. And also, we have Poseidon OS as well. So with this, we want to build both storage pool and compute pool in the data center. For this, we will continue to improve and expand our Poseidon OS to support various types of innovative devices like ZNS QLC, Smart SSD, CXL memory, and so on. And we know the importance of contributors from outside Samsung, so we have a plan to open not only storage system, but also valuable tools for the developers. So Trident is test tool for developers, and it provides test cases and test platforms as well. So you can very easily test your Poseidon code, your own Poseidon code without NVMe drive with Trident, and it will be open sourced soon. Yeah, we have a very concrete feature plan for our project to leverage modern technology in NAND flash. So as I mentioned before, we will support more innovative devices, and we will develop more valuable features and provide developer tools for the outside developers.
So as I said, we have some plans. So we will open source Poseidon V2 next year and POC in data center. And we also want to upgrade our toolistic design by having feedback from community. So just stop by our booth if you want to play with our toolistic design. And I'm more than happy to answer any questions from you. Is there any questions? Yeah? You're good? Okay. Thank you very much.
Thank you.